All right, guys, here's an example of integration by parts. So you always want to try, when you're getting ready to integrate, you should always try to simplify your integrand. Because if you got multiplication, sometimes you can actually multiply it out and get something that you can just integrate with the power rule or something similar. But when you can't simplify and you still have multiplication, it's not 100% guaranteed, but a lot of times you'll end up having to use parts. So what part says to do is to pick one of the two expressions. So there's two expressions here. There's an x cubed and then there's a log function. And what it's saying to do is to pick one of these to be u, right, and one of these to be dv. Now what that means is if you look at what's going to happen on the other side of the equals, we need to know the integral of dv, meaning we need to know what function is the antiderivative of what we declare dv to be. But then we also need to know what function is the derivative of u. So it needs to be that we can take the derivative of u easily. We can integrate dv easily. And what happens is the idea is this new integrand that we get. So it's an integrand within our work. This new integrand should be easier than this original one that we're working with. So that's the whole idea here. All right, so the first thing with parts is always declare what's u and what's dv. Now, there's a hierarchy that you'll see in your notes this week of what is a good idea for u, what's a good idea for dv. So anytime that log is present, you want log to be your u function. And then dv would then be, okay? So in my setup, the first thing, that's my u and v. So next thing is u and v. All right, so I need the integral of dv. I need to know what function has x cubed as its derivative. Well, that's going to be x to the fourth over 4. All right, so that's v. So uv is going to be u. Here is v. So uv is going to be log x times x to the fourth over 4. All right, so there's that part, uv, minus the integral of v. So there's the x to the fourth over 4 again, times du. All right, and now that's the first time that we need the derivative of this. The derivative of log is 1 over x. And that's what I need here with v. I need 1 over x dx. All right, so I'm just going to write this as x to the fourth over 4 log x minus, now this is the simplification here. This is going to be an x cubed, and I'll pull the 1/4 out. So 1/4 the integral of x cubed. Now I can do that. I can do that integral. That is also x to the fourth over 4 plus c, because I'm finally down to the last integral. I've done the last integration step, so I'm adding the plus c. Now it's just a little simplification. All right, and then in both of these, there is a 1/16 that I could factor out and an x to the fourth. So I'm going to pull that out and call this x to the fourth over 16. All right, in this first one, I would have a 4 log x. And in this one, I would have just 1, so minus 1 plus c. All right, that's how I would write the integral, but the last step, either one of these would be perfectly fine for that answer. All right, but that's integration by parts. The big thing with parts is I've got multiplication in the integrand. I can't simplify it. And I can easily see one function that I could treat as a derivative of something, and one function I could treat as a function that I can easily find its derivative. And that's the process, is to make a new integral with an easier integrand once we've simplified it in the parts formula.